The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone, and welcome to this Sans at Mic talk, NoSQL injection in MongoDB applications. Today's featured speaker is Adrien de Beaupré. If during this webcast you have any questions for our presenter, please enter them into the questions window at any time. Your feedback is very important to us, and I'll be putting an evaluation link in the chat window for you to complete. Please note that this webcast is being recorded, and a copy of the slides and a recording of this webcast will be available for viewing later today on the Sans registration page. And with that, I'd like to hand the webcast over to Adrien.
Hello everyone, thanks for coming. Welcome to my talk on modern web application penetration testing. This is a segment from a course at SANS SEC or Security 642, the Advanced Web Application Penetration Testing, Ethical Hacking, and Exploitation Techniques course. This is relatively new content to the course. I am one of the co-authors and one of the instructors who do this course. That being said, I was asked, do you say SQL or do you say SQL? And oddly enough, when I'm talking about relational databases, I say SQL. When I'm talking about non-relational databases, for whatever reason, I say NoSQL. So NoSQL injection will be the topic of today's content. And I also want to clarify that, although this is part of a course, there is other content, of course, in the course besides NoSQL injection. This is one of the topics from day one. My co-author in crime is Moses Frost, who's extraordinarily talented and very well known in both the cloud and web application penetration testing fields. So let's dive in a little bit. Why talk about NoSQL? First off, a couple perhaps things to clarify about NoSQL. There's no necessarily any standard up between them. There's not really necessarily a common query language. This is quite opposite of SQL, whereby most implementations of SQL have the structured query language as their language and have some standards that they abide by. In a survey, we have found that this is not necessarily the case. So some security features we might desire in databases might be authentication. For example, authentication between the application and the database may or may not be required depending upon the database and how configured, and may not be enabled by default. There may be additional components or a proxy required for authentication between the application itself and the back end. In access control, many databases do not have a concept of authentication and thereby also don't have a concept of access control or authorization. Pretty much anyone can do anything, which may be a bad thing if someone decides to delete things or even worse, make changes. There may or may not be any logging, may require additional components or configuration, and may or may not be enabled by default. May require a proxy between the application and the database to do so. Some of them may do encryption between the application or the client and the actual database server. So TLS may or may not be built in, we don't know, or we do know, but not all of them do have it. And within the database, there may or may not be any form of encryption inside it. So data encryption. This is a little bit different from what we've come to expect from relational databases. However, there are reasons for doing so. Many people will talk about NoSQL databases as being web scale, meaning they can scale up and go significantly faster than traditional relational databases. So this is a database global ranking from a well-known site that I just took a copy and paste. And we look and we see what we expect. So for example, Oracle, MySQL, Microsoft SQL Server, and Postgres are number 1, 2, 3, and 4. MongoDB is number 5. Now I had to think back. I'm pretty sure I'd never heard of Mongo before about 5, maybe 6 years ago. And here it is, top 5 databases in the world. That's interesting. I was also still surprised to see IBM DB2 is still there, but you know, the old traditional mainframe databases are still around. You know, the old iron is still kicking. Then the last 4 are also of interest: Elasticsearch, Redis, SQLite, and Cassandra. Now, SQLite, I enjoy it for very small use cases, but I haven't found it scales very well, so I'm surprised to see it's used by actual web applications. That being said, Microsoft Access has been on this list over the past few years, and it's now dropped off. And also, I don't consider that a very usable database for an online web application. So if you look at these, okay, the first 4 relational, then we have number 5, document, number 7, search engine, number 8, key value, and number 10, wide column. So not only are they not relational, they are different kinds of databases than each other. That's of interest to us. So MongoDB is perhaps the most popular. It's certainly one of the most commonly implemented document-oriented databases that we've seen. When I installed it and made use of it in applications, it was really easy to use and set up. One perhaps less desirable implementation configuration option was that older versions of Mongo would bind to all IP addresses, meaning it would actually be available on your public IP address with a port open without authentication or access control. So what happened is perhaps a friend would scan for particular ports and find Mongo open and do bad things to it. So MongoDB, very, very popular. It's a document-oriented database, and it stores in JSON, which is JavaScript Object Notation, or binary JSON, which is a different data format than we normally see in databases. The schema is very dynamic, meaning if you inject new values, they will in fact change the schema. And here's the other interesting feature. It uses JavaScript. So now we have JavaScript not only client-side, where we have, in fact, MVC frameworks in browsers. We also have MVC frameworks in JavaScript on the server. We have JavaScript servers like the V8 engine, also known as Node. Now we have JavaScript doing things in the database. So it's become a very popular and very usable programming language. And here's an expression from a very old, but at the time, funny movie, Mongo, only pawn in game of life, which is, of course, what Mongo says. So traditional SQL is made of rows and tables and is considered to be ACID compliant for atomicity, consistency, isolation, and durability. Maintains consistency even if it limits scalability. So what does that mean? Well, it keeps a journal. And if you suddenly cut power to database, it's quite likely you can recover a significant portion, possibly even all of your data. And it tries to write things to disk. NoSQL is a set of key value pairs. As I mentioned, JSON, we're going to see that in the demo. I'm going to show you the actual format. React, which is another NoSQL database, has buckets. And their design principle is basically available, soft state, eventually consistent. In fact, many of them prefer to keep data in memory as much as possible and prefer not to write to disk being very slow. So we trade consistency for scalability. In fact, if you do 10,000 queries against a specific implementation of NoSQL, it's entirely possible you will start to get different answers at some point, depending upon how the data is stored and how it's moved around. So examples of what it actually looks like. Here on the left is a traditional query, select from users where ID equals 1. And most often the applications, the values would be injected into the ID equals value, the 1. To update a user, we again have a where clause, and often we inject into the where clause. So here are 3 examples with a select, an update, and a create. The equivalent syntax in Mongo would be db.users.find, and then here you have the round brackets. Inside the round brackets, you have JSON, user ID : 1. To update, db.users.update, user ID : and then something that you put in. Set the password to something you put in. And db.createCollection. Now, in old versions of Mongo, you could actually use the db. Commands from an interface, like for example, through the mean stack. The mean stack includes Mongo. It includes Mongo. Express is the JavaScript MVC, or Model View Controller. You have Angular, which is the client-side MVC in JavaScript as well. Then you have N, which is Node, the JavaScript server. In this way, the Node and Express application could actually interact with db. Commands. That has been turned off in 2.x and up. So our injection, we want to make use of the features of the application and the features of the database. In some cases, penetration testing, we simply log in and make use of interesting features. In Mongo, many of the application languages that interface with Mongo will use an injection into a where operator, where parameter becomes a value in a where clause, very similar to SQL or SQL. Now, the db. Commands and MapReduce commands will not be there, but we can often use operators. And in this case, it's a feature of some languages. If you examine the URL on the bottom, http://victim.tld/login?user. Well, so far that looks pretty familiar. The different part here is user $$NE equals 1. So normally you'd say user equals 1 and put password equals something. In this case, it says user, and the square bracket means I actually want you to give me an array, not a single value. Give me all of them. All of them, $not equal 1. Now, this again is very dependent upon the version and the type of operating system and programming language in use, and the database in use. So if the, let's say PHP, for example, application allows it, it may actually go and retrieve from Mongo and say, hey, I want everything not equal to 1, which may return a large array of users. So there are things to try with Mongo NoSQL injection. For example, try injecting logic through JavaScript. Try injecting valid JSON and see if it's actually sterilized or sanitized server side. You might try and trigger syntax errors such that you see the errors back at the client. This has not been true of SQL or SQL injection for many years, where we now have blind SQL injection. There is also the concept of blind NoSQL injection. We can try and insert logic. So in this case, very similar to SQL injection, quote, or, quote, one quote, equal, quote, one quote, semicolon, // might make the entire statement or the entire where operator turn out to be true. You can comment out. Here's a list of some of the available operators and some of the old Mongo commands that were available up to, I believe, 2.3 or thereabouts. So a lot of things to try. Similar to SQL injection, we have a methodology. We want to have a valid request for comparison. So this is our baseline. So we, for example, have a valid request that is able to do something in the application. We then will fuzz it or introduce other strings to elicit other responses. So with fuzzing might try and elicit syntax errors, responses from the databases. We might want to inject operators into perhaps arrays in the parameter names to modify the query, inject JavaScript and other logic to return multiple records, perhaps modify the schema, delete or modify records, which is extremely dangerous. Inject JavaScript again, inject JSON or JSON directly in. And often applications that come with REST or other API interfaces for management, so you might be able to skip this entire step and just log right into the database and access it directly. There are some tools out there. I gave this talk not too long ago, and a friend of mine, Rick, mentioned that OWASP Zap now has support for NoSQL queries. So there's two that I found that are Python based. There's NoSQL Map, there's the NoSQL exploitation framework, there's the FuzzDB list of injection strings, which is not all that big and tends to only have Mongo based or MongoDB based queries. There's the Burp Suite Pro scanner, and some of the automated scanners, I'll call out, say, one of them, Acunetics, for example, also has some support for NoSQL MongoDB-based databases. So vulnerable applications, I was looking for examples to use in class. I came across a few of them. One was written by my friend Robin Wood, also known as Digi Ninja. And Robin wrote the application for this course that we're going to use as part of the demo. There were some bundled into NoSQL Map, which I've also used. There were some on the WebSecurify blog post on NoSQL injection, and there are probably many others. But one of the things we want to point out is this is not just a hypothetical attack. We have an actual CVE that we can go and look at. And then CVE, I just did a query on CVE for NoSQL injection, 1.0.4.3, and this one popped up. I'm going to show this to you. Move to window, new window. So here's the CVE. Rocket.Chat server version 0.59 and prior, vulnerable to NoSQL injection, leading to, ooh, cool, administrator account takeover. That sounds interesting. So it's CVSS score, meh, you know, it wasn't so hot, like 7.5, but depending upon, if you use CVSS V2 or V3 or V3 plus, you're somewhere between, let's say, 7.5 and let's say 9.5-ish or 9-ish, depending upon, because not just information disclosure, you can actually reset the administrator account's password to your choosing. Now that sounds interesting. So discovered by Steve as S. Barbeau. I tried going to his blog recently. If you try that link, his website seems to be really, really slow these days. So he actually discovered this in 2017. He notified Rocket.Chat. They posted the fix in March of 2018, and it's been fixed ever since. So what I had to do is, of course, go back and get an older version of Rocket.Chat and take a look at it. According to Rocket.Chat's website, they are one of the most popular competitors to, let's say, Slack as a chat platform. Fairly feature-rich and apparently quite useful. I've only used it to do exploitation demos, but other people use applications for more productive things than pen testers do. We are probably the not the most common use case. So let's see if I can get my VM up and running and show it to you. There we go. So let's go not straight to the answer. Let's go to Rocket.Chat, and I'm going to go to just home. Okay, I created an account, so I can just log in. Okay, so I'm logged in, and I can chat and see stuff, and look at channels and send messages and whatnot. I see there's a bunch of admin users. Ooh, cool! I like admin users. So taking a look at that, I want to talk to the server, but I also want to talk to it through its API. So its API is documented on the website. It is not Swagger, OpenAPI, or WSDL or Waddle available. It's basically you just have to do, for example, curl, and in this case, I'm going to proxy it through burp. Point one, I apologize in advance. I am the world's worst typist. Rocket.Chat 2.org. It's on port 3000 /API/v1/ So I've got two screens going, and whoops, I didn't want to do that at all. I wanted to stay there. I'm also a bit of a spaz. /info. So we see that we are the correct version, and we see that we can access the API. And as importantly, I now have that request in Burp, so I can look at it. So I can go down here to, there we go, the get request, get the API. So that's all great. Right click, we're going to send that to repeater. And I'm going to do a send just to have a baseline. So we know that we're using the correct syntax. Now I'm going to change my get, and having looked at the documentation for this API, I can do a /login, and I need to put some data in here. This again is going to be in JSON format. So, oh, and this is going to show you my username, of course, and my password. Oops. Fortunately, I think much faster than I can type. So I think I'm typing one thing, but I'm actually typing something else. There's my password, obviously based on password. So username, colon, the username, comma, password, colon, the password in JSON format, hit send, and I get two things back, user ID and auth token. So I need these to construct further queries against the API. So the next one I'm going to do is a get against the API. Once again, I've looked at its documentation on how to access it. It's users.info. And I do a question mark on myself, because I know my own user ID, equal. And I have to put in that token. I'm going to cheat a little bit. I've done this before. And go in here and just put in those values have changed. Nope, my username's the same, but my auth token has changed. And there I put in the auth token. This is a get, so we don't want any data in there. And hit send. Ooh. Hit send. Okay, now I have a massive fail because I used lowercase get by accident. Oh, isn't that interesting? Huh. User ID, user ID, user ID. Oh my goodness. That's me typo again. This is a fail. So now I have access to my own user ID. This is where we actually do the injection. Right here, where I change this to users.info, users.list, sorry. Query equals roles, colon, Node.js when embedded within. And then here's the actual injection, $in. I know, sorry, I know my typing is painful. Admin. No space, it's in the URL, in the, what's called, yes. done this enough times, I can find my mistakes pretty quickly. So I find all the other min users, I can now list their info. But here's the actual magic is right here, is $in, right? Find all the roles where they are admin. And this is the actual NoSQL injection right there, where it allows $in as an operator. And in the case here, not as part of trying to make it an array here, but I want to return this bundle of JSON on all the users. So there's all the other admin users I created for people to play with. But the default one there is admin. I'm also going to try another trick here. I'm just going to copy and paste again so we don't have to experience my horrible typing. So again, roles in admin. Now here's, again, looking at the documentation, fields, send me the encrypted password and the email address. So I hit send. I could probably crack that offline. Now I have their email address, still have their ID. So what I would do then is reset their password. So here, log out. Click on forgot my password, the email. Whoops, what am I doing? That's my email. admin@sc.sans.edu, reset password. Back to login. And I do one more query. And with this token, I can now reset that person's password and I've become them. Now again, the real magic there was in the $in. Do one more demo just because I also have the other application available to me. So this one is the one written by Robin Wood that we also use in class. There's a couple of examples here. One is guess the key. Your guess, I don't know, foo, and it says no match. And I see guesses foo up here, all right. So let's try a syntax error and see what happens. We have a stack trace and it says var guess equals quote, quote, quote. Well, why don't I say var guess equals quote, semicolon, return the key, semicolon, slash, slash, because the key is something we want from the database. It says there's the magic term. So that's the first example from this application. There's user lookup, and they're telling us a SID is a valid user. So I'm going to try invalid user, presumably, of foo, username invalid. Valid username of SID, I see SID works. So let's take a look at these parameters we have to play with. Completions. Oops. Keep forgetting where I put this. So I switched VMs recently, so a lot of things are not, there we go. So user, it's type equals user, and username equals SID. So if I want to find all the usernames of who are not SID, what I do is go in here, $NE, and I want to get SID, so I'm going to say users who are not foo, because I know foo is not a valid value. And I see all the users, but I don't see the administrator. So if I wanted to change that one, same idea, type $n equal and not equal foo. Actually, I could say dot equal foo and get all of them again, including those who are not users. Whoop. forgot a bracket. There we go. So now we have the administrator, who is Penny. One last demo. Log in. So we know foo is not a user. User not found. Excellent. We know Sid is a user. We don't know their password. Wrong password. So if I want to take a look at what's here, there are now 3 parameters. Type equals user, username equals Sid, password equals password. All right, I want to be someone else. So let's say, for example, $NE user, and I want to be not Sid. But I don't know the password yet, so I'm going to leave that blank for now. Wrong password, which means the username is valid, the type is valid, username is valid. So it passed 2 checks there. To pass the 3rd check, I'm going to have to say, for example, quote, or quote 1 quote equal quote 1, and see what happens. Now I'm saying all that stuff or 1 equals 1. And we're logged in, and we have, phew, another demo successfully worked. I jokingly say that I should sacrifice a virgin goat before doing a live demo, but they'll never give me a virgin goat, and of course I would never hurt a goat, because that's just ridiculous. But that is my demo. I've given this talk a couple times, slightly different every time. This one's probably one of the better ones since the demo worked, and I added in the Rocket.Chat content, which was not in the last demo. So we have plenty of time for questions. I tend, and any clarifications, because I tend to go fairly quickly through this stuff. And I make a lot of assumptions about knowledge of burp and exploitation techniques and web apps in general. Let's leave it at that slide for now and ask for any questions. And I'll stop talking for a second.
Thank you, Adrien, for that brilliant presentation. I'm just checking the questions box now. We actually currently don't have anything that needs clarification right now. So if anyone, we still have about half an hour left here. So if there is anyone listening that has a question, make the most of your time here now to ask it in the chat window. We'll just give it a couple of minutes, just a couple of seconds even, just to sort of wait for these questions to come through. First question, what was the URL for downloading the vulnerable setup?
Yes, the vulnerable application for the one I use in class is robinwooddg.ninja. So this is Robin's website. Under his projects, he has, oh no, it's labs, I'm sorry. There's Authentication Lab, Cores, Graph, Socket to Me, Phone App, and actually it's in this GitHub. And I'll have to go looking for it. I don't want to log into GitHub right now. But so there's one on GitHub. The other one is a Docker, which I got from the Rocket.Chat GitHub. And the third one comes with NoSQL map. So if you install NoSQL map, it comes with the PHP files. If you look at Robin Wood's Digi Ninja, look at his projects, in GitHub, his repos. And the third one is Rocket.Chat version 5.8.581. And I got that from their website in GitHub.
Great, thank you. A couple more questions coming through now. So how do you know if the app is using MongoDB?
So that's a really interesting question, and it's a common to all injection attacks. first, how do we know what it's running? And second, how do we know which attack to try? In this case, so going back to the first demo of Rocket.Chat, it's in their, it's literally in their documentation. So this application, really reading their documentation, tells you that they're using Mongo and tells you the information you need to access the API, which is where the attack actually occurs. This application is also really interesting to take a look at if you want to take a look at WebSockets, because it also makes fairly heavy use of WebSockets back and forth. So an interesting application to look at for WebSocket vulnerabilities. I haven't actually looked in there yet, but I would not be surprised if there was something interesting in there. Now, for anything else, for example, this one, it's really the first one that's the key. By typing in this, getting syntax error, and looking at, oh, there it is. Other things might tell you about port scan with 27017 might be open. So reading documentation, trying injecting strings. Sometimes perhaps your automated web scanner might indicate what it finds. You know, automated web scanners are a critical part of our toolkit, but they often are only interested, only as interesting as far as they might point us in the right direction of saying this page has got something interesting on it. So these are, three of the techniques you can look at, or just ask, if it's a relatively dark gray application pen test or a bug bounty, you might have to ask for documentation and or just, interview the owner or developer. Otherwise, it might, when worse comes to worse, a lucky guess, which I hate to say, but the methodology for trying to figure out which type of attack to try, actually, I'll pop up a totally different slide deck to get you to that, where I wanted to show you what the mantra is. So the mantra for how you figure out what tool to try is way down here in this class, but I put it into pretty much every time I talk. So in any pen test, bug bounty, or CTF, where are you in the methodology? Are you in the application scanning mode? Are you in the vulnerability identification mode? Are you in the exploitation mode? Find out the objective, add in what do you know about the application, which may be very little, it might be a lot, and then which techniques will allow you to apply that goal. So one of your first goals is often information disclosure, where the automated scanner or your own good guesses and experience will tell you perhaps what information will be available from the application itself. And then you find the tool that applies the technique. Too many people try and do the reverse. They try and pick their technique or pick their tool first, and then go back and try and achieve an objective. That doesn't always seem to work. It's better if you know what you're looking for first, and then try and work out how to get there.
Mm-hmm. Great,
really
thank
good
you.
Questions.
Yeah, definitely. We have just one more here. If anyone else does have a question, now is your time to ask it. Question from Dominic here. What are good defense mechanisms?
I think and I won't get too specific into Mongo itself, the most general defense mechanism is to sanitize any user input. For one case, do you allow the trick I did with the PHP to turn things into arrays? Are you even aware that PHP can do that? And most languages would not. Inside the JSON injection in Rocket.Chat, we had the ability to insert the $not equal. Well, you probably want to restrict operators from being injected where there should be parameter names or values. So it's all a question of doing an allow list and a disallow list of things that used to be, we used to call that a blacklist and a whitelist, of making sure that what they're injecting these parameters is a valid value and is allowed. More specifically, there are web application firewalls, there are RASPs, and other technologies that you can introduce to try and lower the risk. But the best thing is to know the application, know what should be allowed, and then disallow everything else.
Great, thank you. I think that's all the questions we have right now. Give it another couple of seconds in case any more come in. But
plenty of time. My email is there. My Twitter handle is there. You can also reach me through SANS. I'm quite easy to find. Normally I'd say, come hang out at a SANS event, but we haven't had them live recently for obvious reasons. Hopefully everyone is staying safe, in a safe environment and a healthy environment.
Absolutely. I think that is the end of the questions today. So I think all that's left is to thank you, Adrien, for an awesome presentation, bringing this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all our webcasts, archived and upcoming webcasts, including this one, please visit sans.org/webcasts. And until next time, as Adrien says, take care, and we hope to have you back again soon for the next SANS webcast.
Thanks, everyone.